Part 1 of Unit 2 is about basic reaction types. In case you've forgotten everything from Chem 1, a chemical reaction involves reactants, we'll just call them A and B for right now. They will interact with each other and atoms will be swapped around between them to produce products. We'll call them C plus D for right now. So the bonds between the reactants are broken. The atoms are rearranged into new molecules on the product side. So reactants are on the left, products are on the right. This is not an equal sign. These reactants yield these products. It's called a yield sign. We're just going to go through examples of the different basic types of reactions. And the first basic type is called a synthesis reaction. It's also called a combination reaction. It's just two or more reactants combining to make one product. So general form would be A plus B yields C. An example of a synthesis reaction, this is a slow reaction, but iron reacts with oxygen over time to produce iron oxide or rust. Two reactants combining into one product. That's a synthesis reaction. A decomposition reaction, it's just the opposite of a synthesis reaction. Instead of two or more reactants going to one product, it's one reactant going to two or more products. So we'll have our general form of C yields A plus B. An example of a decomposition reaction, carbonic acid, H2CO3, readily decomposes into water and carbon dioxide. We still got the same amount of atoms on each side of the reaction arrow, but we've gone from our combined reactant to the two different products. So that's a decomposition reaction. In a single replacement reaction, we'll give it the general form AB plus C, that looks like an L, plus C yields AC plus B. We're going to have one compound that's two things combined together, usually a binary ionic compound, and some reactant that is by itself. The thing that's by itself is going to replace one of the two parts on the other reactant. They're just going to switch places, so there's one replacement going on. An example of this would be silver chloride. Let's say we had some silver chloride solution. This AQ symbol down here means aqueous solution. It's silver chloride dissolved in water. And to that, we're going to add some solid copper. What's going to happen is copper is going to switch with one of these two reactants. The way we know which reactant it switches with, it's going to switch places with the ion that has the same charge. Copper is a metal, it's got a positive charge, so does silver. So copper and silver are going to trade places. Copper's not going to switch with chlorine because chlorine's got a negative charge. So we're actually going to end up with copper and chlorine together as our aqueous solution, and we're going to produce solid silver. So that's our single replacement. There's one element in a reactant being switched. Sometimes it's called a single displacement reaction. In a double replacement reaction or a double displacement reaction, two things are going to switch. Let's give it the general form AB plus CD yields. And now to figure out the products, we're going to have two things of identical charge switch. So B and D are going to trade places. So we're going to end up with AD plus CB. These would be the ions with negative charge. That's why they were written second. They're going to trade places and swap on the product side. An example of a double replacement reaction, if we had two solutions, we had a solution of lead nitrate. This is lead 2 nitrate. It's got a +2 charge. An aqueous solution of that is going to combine with a solution of potassium iodide. When we pour these two solutions together, the iodine and the nitrate are going to trade places. So we're going to need 2 iodines to balance out the +2 charge on the lead, and the nitrate is going to come over with potassium. Now, in this reaction, we started with 2 solutions that we poured together. When you actually perform this reaction, the lead iodide makes a yellow solid, so we write a little S in parentheses to show that it's a solid. The KNO3 stays dissolved, so it remains an aqueous solution. You need to memorize the solubility rules that are on your handout to figure out what's going to be solid and what's going to be aqueous as the products in a double replacement reaction. A solid that forms in a double replacement reaction is insoluble. It's called the precipitate. So if something's an aqueous solution, it's soluble. We're looking for the insoluble precipitate in double replacement reactions. Acid-base reactions are special examples of double replacement reactions. They have the same general form, but it's a reaction between an acid and a base. We don't have acid-acid reactions or base-base reactions. Nothing would happen. It's got to be an acid and a base. So let's look at a simple one. HCl, that's hydrochloric acid, reacting with KOH, potassium hydroxide. It's going to act just like a double replacement reaction. Chlorine is going to switch with the hydroxide ion. Both of those have a -1 charge. So we end up with KCl on the product side, and our other product is going to be HOH, or if you want to write it differently, H2O, water. So a acid-base reaction involves aqueous acid and base solutions reacting to form another solution. These are usually soluble salts. Any ionic compound can be called a salt, and if they're dissolved in water, they're soluble. So this is the soluble salt potassium chloride, and water is always going to be one of our products as well. And since water is a pure substance, we can go ahead and put the L on there for liquid. So acid-base reactions are a special type of double replacement where you end up with an ionic salt and water as your product. Combustion reactions. These are reactions that involve a lot of energy change, like explosions, or something more controlled like the gas stove in your house. A combustion reaction happens between a hydrocarbon, which is something that's got hydrogen and carbon in it, and oxygen. So let's look at this example, C2H4. This is acetylene. It's used in torches. It's going to react with oxygen to produce, this is the easy part about combustion reactions. The products are always the same as long as it's just carbon and hydrogen in the hydrocarbon reactant. Your reactants are going to be CO2 and H2O. That's it. They're both gases. Ran out of room to write those below there. But all of these are in the gas phase. We have C2H4 reacting with oxygen. Now, for a combustion reaction to happen, we need a source of heat, a spark or a match. We show that with a little triangle above the reaction arrow. So this means that acetylene and oxygen, when provided with a spark or heat source, will produce carbon dioxide and water. This is called complete combustion. Incomplete combustion results in the forming of CO, carbon monoxide, and water. So it's safe to assume complete combustion unless a question tells you specifically that it was incomplete combustion, which would form carbon monoxide. The question for this section is, copper 2 sulfate solution is added to a solution of sodium carbonate. As a result, solid copper 2 carbonate precipitates and sodium sulfate is present in aqueous solution. What type of reaction is that?